Welcome class to IS341, Software Engineering 1. And I just want to say hello again to a number of familiar faces there that I've seen from various object-oriented classes that I've taught in the past. So now we are going to kind of take a step back in this class. I wanted to kind of introduce you to really what we're going to be talking about. This is going to be a shorter video, just really an intro. So what is software engineering? So now you've been really focused on development and implementation and programming languages. The way I like to look at it is we can actually compare ourselves to normal engineers. So if you think about materials engineers, electrical engineers, mechanical engineers, a good way to kind of envision this is that anybody in the world can really put together a motorcycle. In Milwaukee we have Harley Davidson out by us. Anybody can really put together a motorcycle, and I mean that bluntly. I could put together a motorcycle. It will take me 10 years and all sorts of money to do it, though. Why do you hire an engineer? You hire an engineer because they can put together a motorcycle for you, test it, do all of the requirements, they can do the design work of it, and they can put together a motorcycle for you in 30 days. That's really what you paid for. It's the same way with software engineering. You can find anybody on the web that can put together a website for you, that can put together a web application, that can put together an embedded application. But a lot of them, it'll take them a year to do it. We get paid, we get hired as software engineers because we are experts and we apply a sound engineering focus that we can design it, test it, implement it all within a set amount of time and deliver upon the requirements. So whenever in the past when I talk about requirements and design, really that's what the engineering process is going to be like. So now though, with that in mind, if you look through the weeks here and even the course learning objectives, we're not going to do a whole lot of coding at this point. We're going to really focus on the sort of more boring or not so fun aspects of software engineering, but they are important. They're going to take up a good amount of your time as you get hired somewhere. Everything from requirements engineering, system design models, engineering dependable and secure software, and service quality and process improvement. That's all incorporated into the engineering process. So let me show you something real quick. So this is a recent survey result, and I'm not going to go into details of the website. I'll post this in my announcement, but this is an ongoing truth of our industry here. More than half of IT projects are still failing. And when they mean by failing, a project failing, that means it's usually not delivered on time. It's usually, or it's delivered over budget, or it's not what the customer was looking for. So what does that mean for us? Is that we have a high failure rate in our industry. So it is our job of engineers to change this. So really what we're going to study in this class is the software development cycle. So for the longest time, you've really focused on number 4 here in the top left, implementation and testing possibly. We haven't really dived into the rest of it, but planning, analysis, design, implementation, testing and integration, and maintenance are all part of that. And one of the biggest things too is that, I don't have a chart with me here, but we'll demonstrate when we get into the requirements phase, these first 2 steps here, or even the first 3 steps, in general, as you progress through the steps, the later the step, the more costly the bugs or the errors that happen. And what do I mean by that? If we find a bug in planning, it's very simple to fix, very easy, and it's very cheap to fix when we look at the long term. Even steps 1 through 3, at that point we're not changing a whole lot. We'll probably find a lot of bugs in implementation. That happens all the time. But once you get into steps 5 and 6, that's where the cost of having issues and what leads to failure for entire projects is, because finding issues here costs so much. Even especially in number 6, we're talking about an exponential growth. So we're not just talking about a linear growth. We're talking about exponentially growing, where the cost is almost multiple times at an exponentially larger than what it was at planning. So we're really going to study all those various aspects of when you can identify when there's going to be a potential issue, or when there's going to be possible problems with the software, because the whole concept is there's various different ways to go about this development life cycle. We'll talk about Agile, we'll talk about the rational unified process, we'll talk about requirements, but trying to find a balance, because there's one of the big things in IT and in software especially, there's no silver bullet. So that's a big thing. There's not going to be one solution that slays them all. We have to find, and that's what we get hired for. Every project's going to be different, but you have to apply these skills where, as you progress through your career as a developer and as an engineer, you can reference those earlier projects and use these skills to really help leverage and say, hey, I know which way we need to go. We've done this before in XYZ project. So this is really where we're going to spend a lot of our time talking about this development life cycle. And so that is pretty much in a nutshell what this class is going to be about. So I hope that you still code during the class, because that really gives you an insight to the various different steps. But you'll notice that a lot of the times the assignments there's no real code required. I just hope that, especially in my philosophy, the sooner you get to at least putting together mock-ups, rapid, let's see, what is the term that I'm looking for? Rapid prototyping. So the sooner you can figure out what it can look like in a technology, with the actual technology, let's say even just as simple as putting together a GUI real quick to show a user what it means, it does lead to better developed software the sooner you get to coding, even during planning. So you can give it, because all of us in our career will be asked by a project manager or even your boss to provide an estimate. So how long is it going to take? Well, sometimes to really get that estimate, you need to start coding right away. And I'm not talking about developing a solution. Just if you get an API and your boss is like, hey, we need to integrate with this API, you should be either reading the documentation or running a few tests on there with some sample data just to get an idea of what it would take, because it's pretty easy to build out software in those iterations. And as you go through the analysis, design, implementation, or requirements gathering, refinement of requirements, then you'll be able to develop the solution more. But you really need to start with just getting a handle on what it could be like for requirements in general, or estimation in general. So look forward to working with all you again. And if I haven't met you, please reach out to me and have yourself a wonderful term.